Welcome back to the machine shop. We're getting the big lathe set up. Look at the size of this thing. We got this Washon 25 by 118 lathe. It's awesome. So there's some problems with this machine before we can just plug it in and use it. By setting it down on this unflat floor, this machine's probably following that floor also. So it's probably been twisted or bowed. Ultimately, we're transferring the ground to the work, so we need to eliminate the variables in between. The floor can be twisting the bed of this machine, but we don't know that yet. This machine has been provided with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 mounting bolts to allow us to bring this machine back into specifications. The floor is twisting the bed. The ways are attached to the bed. The carriage rides on the ways. So from the carriage to the tool, which then transfers into our part, which gives us parts that aren't being machined accurately. So it all starts at the floor. So the first thing we gotta do is move this lathe in place and bolt it down. Alright, I don't want this thing to move. Now it's time to bolt it to the floor. The bolts are inset underneath the frame or the skirt, so you can't get the rotor hammer to bolt down into it. So the previous owner of this lathe has built this base plate, and it moves the mounting locations external of the frame so we can drill in here. So we're just going to use the rotor hammer here, and we're going to drill in with this 1/2 by 6 wedge anchor right through the hole and into the floor. I drilled extra deep on these so that if I do ever want to remove this lathe from this location, I can lift the lathe up and then I can actually pound this wedge anchor back down into the floor flush. I don't have to come back and cut it off. So because this base plate right here is bolted to the floor, now I'm able to suck the machine down or push off the floor and pick it up. The tool I'm going to use to read what the ways are doing is just a simple level. Now a lathe doesn't necessarily need to be level. They put these machines on ships, submarines, a whole bunch of surfaces that are always constantly changing. So technically we could stand this thing on its end and it will perform accurately. We are going to use the level itself because it is a good reference tool for us to be able to make sure that there's no twist in this frame. Once we see what the level is reading, we can paint a picture of how the machine is twisted. And from there, we can adjust the leveling feet to bring it back into factory specifications. These boards are representing an exaggerated view of what the way could look like. We could have a bow in it. We could be like a rainbow. One could be straight, one could be bowed, one could be arched. There's too many variables, but I don't know what it looks like. I'm really hoping the ways on this machine don't look like this. So in order to read the ways, you just move the level and you read what it's doing. And as you can see, the closer I get to the center, the level starts reading level. But then the more you move it down, it reads on the opposite. It moves from one side of the scale to the other side of the scale. And what that tells me is there's a crown in it. And it paints a picture in my head of how I want to manipulate the feet to take that crown or sag out of the ways. So I want to be using these flat surfaces here to measure with the level. But unfortunately, this V-way blocks the level from sitting on them. So we use the 1, 2, 3 blocks to raise the level up to clear the obstruction. I'm gonna start off at the far ends of this machine, and I'm gonna use a level that has a really wide scale on it to get me close, and then we'll switch to a more accurate tool to really dial this machine in. We got the lathe roughly in the position that we want with this level. We're ready to switch to a more accurate instrument. All right, we're sitting good. We got the machine calibrated in, got all the twist taken out of it. We need to make some test cuts, and we need to kind of let the machine settle for the next couple weeks or so to kind of make sure everything's sitting right. After we make the test cuts, we'll be able to see how accurate the parts are. We still have some variables we can change. We have headstock alignment, we got tailstock alignment. There's some great videos out there. Check out ABOM79. He's got some great videos on how to align your headstock and tailstock. But for now, we're sitting good. I know that I'm comfortable that the bed doesn't have any twist in it. When we start making test cuts, we might actually have to twist this thing to make it cut straight, but we'll save that for another video. Thanks guys for watching. Be sure to check out fireballtool.com. Please like and subscribe if you aren't already, and we'll catch you on the next one.